I want to do exercise number 3-6 with you because there is a certain procedure I would like you to follow. We're going to call this procedure fraction busting. And it's a skill that you will have to demonstrate before you can get a license for using cross products, because you'll have to prove that cross products does the same job. So, when you see proportional equations like this, the goal should be to eliminate the denominator. So I need some multiplier, and the multiplication property of equality if I multiply both sides of this first example from 3-6, if I multiply both sides left and right by 3, because 3 is in the denominator on the left, I will have a reducible value on the left, because 3 over 3 is equal to 1. I can replace 3 over 3 with 1, and I'm left with just x, or 1x. Now if I scale the left side by 3, I also have to scale the right side by 3. So my result is x equals 18, and I'm told to verify that that is the result. So I have to replace x with 18 in the original equation and perform that check. 6 equals 6, indeed it does. I'm going to use the fraction busting technique over here on the left. If I have a simple factor of 2 in the numerator, then I'll have a reducible result on the left. The multiplication property tells me if I scale the left side of the equation by 2, I also have to scale the right side of the equation by 2. So if I double what's on the left, I have to double what's on the right. 2 over 2 is equal to 1. I'm left with 5x plus 9 equal to my doubled result on the right. Subtracting 9 from both sides, 5x equals 15. Division property of equality, x equals 3. I need to verify in the original equation, not one of my changed equations down here, not this guy or this guy or this guy. I need to take my result, x equals 3, and test it in the original equation. Plus 9, 24 over 2 equal to 12. 12 equals 12. Indeed it is. Now, these examples will get more complicated when the denominator is a binomial. Right now, we've got some pretty simple exercises. Taking a look at the third one, x over 4 equals 9/6. I need a value that will cancel both 4 and 6. So one possibility is I could simply multiply by both 4 and 6, or I could consider multiples of 4 that are also multiples of 6. So I think that what I'd like to do, instead of multiplying by 24, I think I'd like to multiply by something that has 4 and 6 as factors. So I'm going to choose to multiply both the left and the right by 12. 12x fourths is equal to 108 sixths. And that's 3x is equal to 16. No, 18. I'm a little suspicious of my result because I'm doing this in my head, but I'll find out when I run my check if I've got the correct value for x. If my value for x is incorrect, this is the step I'm going to look at first. So is it true that 6 over 4 is equal to 9 over 6? 3 over 2, if I divide both numerator and denominator by 2. So again, technically I'm dividing by a value equal to 1. 9 divided by 3 is 3, 6 divided by 3 is 2. Yes, indeed, they check. This one's kind of fun over here on the right. I need to multiply by a value that will cancel the 8 on both sides, and a value that will also cancel the x, which is on the left. And because the multiplication property tells me if I scale one side one way, I must also scale the other side the same way, my lowest common denominator is 8x. So 8 times 5, 40. X divided by x is my first reduction step. And 160, x divided by 8 is my second. So I have 40 equals 20x. Division property of equality tells me that if I divide both sides by 20, I can isolate x. So is 5 over 2 the same as 20 over 8? This fraction is reduced, so let's reduce the one on the right by a factor equal to 1. This equals 5 over 2. Yes, indeed, they check. So I hope you took notes along with me. This is the procedure you'll be expected to follow. It is called fraction busting. This is what I want to see on your paper for exercise 3-6. This is what I'll be looking for on independent assessments, and this is what I'll be looking for on the next take-home, which is a fraction busting technique take-home.